So today we're going to talk about hardcore tech challenges in fully on-chain gaming and basically why building on-chain games sucks today, but also why it's interesting. And secretly, this talk is every on-chain game wants to be its own rollup because making a game on a rollup has a lot of benefits that we'll get into. But also right now, it's still a big challenge. So who am I? Where is it coming from? So I'm Norswap. I'm working on 0x Fable, which is a fully on-chain trading card game. So something like Magic the Gathering or Hearthstone. I guess if you're all nerds here, you pretty much have heard of something like that. But doing this right is a ton of work. And doing this right means like doing this in a way that's decentralized, not fully centralized, and then we just have NFTs, but just putting everything on the blockchain. Why do we want to do that? Like, that's kind of crazy. Put everything on the blockchain. It's a very difficult platform to work with compared to just using the traditional tools that we have. And I have a talk at Denver that explains why I want to build on-chain games. This is not the topic today, but like to just give you an idea, I think the best reason to build on-chain games is we want to be able to extend the game. The game does not just belong to the author of the game, it also belongs to a community that can change things in the game. And so for my game, it's a card game, people can create new cards, but they can also create new game modes that use existing cards. So this sort of gives you an idea of why I want to do this. So what are the challenges? Like, what's difficult with making on-chain games? Well, first of all, players will make a lot of actions. So your chain needs to have sufficient throughput to make sure all the actions go through. Secondly, these actions cost money. Making a transaction on a blockchain costs money. And we might not want that, right? If you play a Web2 game, especially like a card game or something like that, it's often free to play. So users don't feel really good paying like 3 cents each time they do an action in a game. And for some game, that just doesn't scale. The third thing that's difficult is making your game actually decentralized. And we'll talk about that in depth. And keeping the costs low. So even if you make it free for the user, you still have costs for yourself, and you don't want these costs to be too high. Then all the classical challenges like traditional gamers that are not already blockchain native, they're not gonna install MetaMask. If you send them to your game and you say, okay, you need to install MetaMask, and then here's this 20-word password, please write it down and store it under your underwear so that you can keep it safe. And then please now go to your bank account and send money. Like, that's just not gonna fly. So you need to make sure that at least at first they can play immediately with no money, with no MetaMask, no nothing, and then later you sort of start adding these things. Finally, games, blockchains are public, but games have secrets, right? In a card game, you have a hands of cards that are known to you but unknown to the opponent. How do you do that? So we need to use zero knowledge, but that's a whole other hardcore challenge. Extensibility, like I said, that's the main reason to make games, but then how do we do that? And then if your game has some economic aspect to it, there needs to be enough trading liquidity. So I said one of the big pieces of the puzzle is to make a roll-up in your own game, to make your game on its own roll-up. And this gives you a few of these benefits, right? I've put the number that corresponds to the number here. So one is gas isolation, meaning that if you have your own roll-up, you're sure that nobody's going to do an NFT drop on your chain that's going to change the gas price, right? Because otherwise, it might be someone drops the new ape penguin NFT profile picture, and then your game is unplayable for 3 hours, and that's just not good. If you're doing a roll-up, you can also customize the chain to do a bunch of things. One of these things is sponsor a transaction, make them essentially free. Another thing is your chain is just for yourself, so the throughput is a lot better than a chain that you have to share with other people. It's cheaper, and we'll see some reasons for that. And then it's customizable, meaning you can change the implementation of the blockchain itself to achieve like these last four here. At least it can help. So a big question is, my thesis was, a game wants to be its own roll-up, and you could say, well, why not its own blockchain? Why does it have to be a layer 2 roll-up, not a blockchain? And the answer to that is related to our goals. Like a roll-up is cheaper and more secure for any amount of cost that you're gonna sink into the roll-up. And this is part of a vision of what I'm building, so that, for instance, to run a rollup that is secure in a sequencer. Sequencer is essentially the entity that builds the blocks, right? And right now in rollups like Optimism, Arbitrum, this is centralized. There's a single entity that does that. This is not good enough. It will change later. But you need to do that. But as a game builder, right? It's good that I need to do that, but then I need to find people, maybe 100 nodes, to run my game. And that's a huge amount of effort. Instead, I don't want to do that. I want to go to a marketplace and say, hey guys, I have this game, it needs to be sequenced. I'm going to pay you as much. Please just permissionlessly register to become a sequencer. And then finally, there's something called shared sequencing. And we'll see what that is. And that allows you to make cross rollup transactions that are secure, so no more bridge hacks, and that are fast. So now I'm going to explain a little bit more, because I'm making a lot of claims, and I'm going to explain why these claims are true. So why are rollups cheaper? When you run a chain, it needs to be validated. And these validators, they can't be Sybils, though you need to make sure that validating this chain is expensive, but then you need to give returns to the stake that people have put. And there's two ways to do that. You can use your own token. Well, this is great because you're just printing money. But this is also real money that you could sell the token to use for other things. And because people are staking your token, they're exposed to your new token. Your token is unproven. You're a new game, nobody knows you. And so they will demand high return because they're exposed to the price volatility of your token that nobody knows. Or you can use an existing token. You could say, well, you're going to stake ETH to validate my game. But then you need to compete with all the other source of returns on ETH, right? Like ETH staking is giving 6% or something like that. And that's like very secure. People are very comfortable with that. So you probably need to offer a lot more. But in L2, you can use a technology called restaking, where on L1, people take their ETH that have already used to validate Ethereum, and additionally they say, well, we'll validate Ethereum, but we'll also validate your game rollup. And if you do that, you don't need to pay the competitive rate, because these rates go on top of the rate that they are getting paid for validating ETH. So rollups are cheaper for that reason. This is what I explained before. You don't want to go to 100 people to find sequencers for your rollup. Instead, you want to go to a contract, a marketplace that will find these rollups for you. And you know, if we don't do this, then basically having games on their rollup is going to be a lot more difficult. So shared sequencing is when you have a sequencer that sequences multiple rollups. So it's going to propose blocks for multiple rollups at the same time. In general, there's many ways to do this, but in general, it's any scheme that ensures that you can take a set of transactions across rollup and make sure they always succeed together, or are included, at least. If you don't guarantee they succeed, you can at least guarantee they're included. And this is useful for bridging. This is the main use case. But it could also be used if you have a game that you split the logic between multiple rollups. Well, you could have cross rollups actions between these things. So this is very useful. This is a lot more technical, and I have a talk about this at the Modeler Summit this Saturday, which should be posted online also. Another thing is if you have decentralized sequencing. And so decentralized sequencing, you have a bunch of sequencers. Typically, you're just going to pick one that's going to make the block, but it's going to be random. And if you do that, what you ensure is that if one falls down, well, you just miss one block. That's not a big deal. And they also can censor you because there's so much of them. So if one tries to censor you, well, big deal. The next one will let you in. So that's how distributed sequencing works. But if you take all your sequencers and you have them vote on the blocks. So one of them is elected to propose the block. All the other ones are going to vote on the block that's selected, right? Then you can use the signature to do interesting things like low security bridging. You just check the signature, verify, oh, okay, these people are sequencers. There's a 2/3 majority. And now I can do a fast bridge. And this is great for games because games maybe don't handle millions and billions of dollars. And so parts of the games may have lesser security requirements. And so this is enough, even if you don't have that many sequencers. It's a lot better than most bridges today, which are like, you know, 5 out of 9 multisigs. Here we're talking about maybe hundreds of sequencers. And they're also bonded, so they can be slashed in case of problem. Spinning a good rollup today is hard. There's only one way to do it, which is the OP stack. There's no competition right now. Hopefully there will be. There's no foolproof in the OP stack. They're working on it. There's no isotronic sequencing. That's what I just talked about. And it requires a lot of tech know-how. There's some rollup as a service provider. There's Altlayer. There's Conduit. There's Caldera. But you opt into a vendor locking. Their tech is not open source. And they don't have sequencing. And so I'm personally working on making these rollups, and especially for games, easy. So I'm doing two things. I'm trying to do some DevOps so that it's really easy to spin a rollup, and I'm trying to work on decentralized and shared sequencing. And I'm looking for people to work on that with me, so reach out. So there are these two projects, right? Like the first one, Sexy Sequencers, is the decentralized sequencer implementation, and I want this to be open source, and I want this to be collaborative with the whole community. And then simple OP rope stack is this configurator to make it easy to spin a rollup. So some more ideas around rollups, why they're useful. Like I said, you can split your game logic between multiple servers. Like a naive rollup by itself will do at most 50 million guesses per second. This is what Binance Smart Chain does, and this is sort of my mental limit of what you can do that's not reckless. So it's about 500 Uniswap swaps per second. And a game might be a lot more hungry in terms of capacity. But if it's not enough, you can add more rollups. You could say, well, my economic layer is going to be on one rollup, and then my game logic is going to be on one rollup. Or if you have multiple parts of the game logic, if you're doing Pokemon, maybe your battle logic is in one rollup, but the word logic is in another rollup. And then these things communicate from time to time. Use share sequencing. There are other things you could do. I'm going to skip over them quickly, like optimistic games, state channels. Just do things off-chain, and then if there's a dispute, prove them on-chain. If you're interested in that, talk to me. Yeah, if you want your game to be extensible, other people have to be able to deploy contracts on your rollup. And this means you can't make everything free, otherwise you're just running arbitrary code for free. But what you can do is sponsor the things that you think are good, and for this use account abstractions. And account abstraction is a way to let people sign transactions, but then they don't have to pay gas for them. Someone else will pay gas for them. Maybe they don't pay gas in the native currency of the rollup. They can use some arrangement. And so this is a big solution. If you spin your own rollup, you can sort of integrate that natively. Yeah, we can expect users to install MetaMask. And so again, account abstraction, smart accounts, is the way to go there, where we give people a way to basically have a multi-sig, including their device and the game provider, instead of having them install MetaMask. And then maybe later we'll let them install MetaMask and we'll reward them if they do that. Another issue that's very hard is handling secret information in games. And so zero knowledge proof right now, they're very slow to work. So in my game, I wanted to prove that you drew the correct card. And that took like 1 minute on like Chrome, in the browser. And it required you to deploy, to download a 3 GB witness file. So that's like not great for something that's that simple. But things are evolving fast. The technology is moving. And so I'm confident that we'll be able to make this thing easy in the next few years. And you can always sort of get more clever. So we fixed this issue in the game. We made it a lot easier. But we had to get really creative. And a rollup also helps for this, because if you add precompiles to verifying zero knowledge proof, it makes it cheaper on the rollup side. And yeah, like I said, things are modified. There's a lot of good theories. There are good papers around this. The thing is, they're not usable by people that are not ZK experts that can't implement the thing themselves, right? There's not a lot of language and tools that you can use to just write circuits easily and put them in your game. How am I doing on time?
There is like 1-2 minutes for questions, maybe, or for finishing up, if you want. We do not yet have the next speaker, or maybe.
Okay, well, if there's questions,
take a few minutes, no problem.
Okay, perfect. So, yeah, my other thoughts were on making game extensible, and if you want to ask about that, I'll be happy to answer. So just to conclude, I think gaming is super fascinating on chain because it's the joining of a lot of concerns are like at the frontier of what we can do. You know, like sharding, account abstraction, zero knowledge, rollups. And it's a way to make something that's truly decentralized. And games are like, they're not super serious. So it's an easy way to experiment. Like, if your game fails because it's not enough decentralized, people won't care as much. So it's the perfect experimentation ground. But it's the first step towards making everything decentralized eventually. Everything owned by the community, everything extensible. Like, I've been a gamer most of my life. And I've played games that I can't play today because the editor of the game just stopped the servers. And that's just heartbreaking. I want us to go from open source, which is the code is open, to OpenStack. Like, everything you need to run the game or the app is open. There's no gatekeepers. And so if you're excited about this, if you're excited about games, but also the technology behind it, this was very much a talk about technology, just talk to me, and I'm happy to answer your questions.
Any question?
One question, if every game was running their own rollup, wouldn't that kind of kill composability between different games? So saying I have one asset from one game that I want to use in another, and they're both on different rollups, that makes it somewhat complicated, doesn't it?
Yes, that's a great point. This is why we need the shared sequencing thing, where there will be builders that build blocks for multiple rollups, and if they see you want to go from game A to game B, they'll be able to propose blocks for these two things together and guarantee that the bridging goes through. There's some challenges there, to be sure. Like, it's not like we know the solution. There's like a design space that's pretty complex with different trade-offs, but there are solutions that are just way better than what we have today, for sure.
Any other question? We're still waiting for the next speaker, apparently. No? Or do you want to add something? Final
No, I
word?
think this is good.
Okay, thank you.